Hello, you guys, and welcome to the integumentary system. We're moving on to chapter 5. I wanted to start this chapter out with the pathologies. Usually I leave it to the end, but I wanted to show you how very important this system is and how dramatic when it goes wrong. So we're starting out with the cancers. And so skin obviously is very exposed to sunlight and to UV rays, and some things can go wrong. So I wanted to start out showing you what a basal cell carcinoma looks like. And this is a diagram of one. Even though I'm not a dermatologist, I wouldn't be able to recognize one just visually, but this is an example of one. So it's the most common type of skin cancer, basal cell carcinoma. And we'll go through and see in a little bit what those basal cells are. It's the least dangerous. It's very common. It's seen a lot. People have little things removed from their faces, from their arms. They have little, cuts to remove some of these basal cell carcinomas. It just looks like a small, shiny bump, really. And it originates from these cells that are the lower cell of the germinative layer. What that means is that's where you're generating new cells. The germinatum, or basal layer, is a layer that has the younger cells that are going to be continually renewing your skin, right? You know that you're in the shower, you're losing a bunch of cells. And so these new cells are pushing up from the lower level. It's that lower basal level of cells where, they're called basal cells, where mitosis essentially goes wrong. So mitosis is the cell division, and it starts to divide excessively. So that's what you don't want to happen. Comparing it with that one, we have the squamous cell carcinoma, and this is on a person's ear here. And this one originates from a different cell, not from those basal cells that are the new cells, but actually from the keratinocytes, which are the most common cells in skin, and I'll be showing you in a little bit. So there's a very good chance of recovery if you remove these also. So squamous cell carcinoma also is something that, with the removal of all these cells, that mitosis stops because the cells that were overdoing that mitosis have been removed. That's squamous cell. The third one is the malignant melanoma. Notice the coloration of this. I'm going to go back a little bit. Look at that. Look at this. So this is the most dangerous of the skin cancers. So if it's a melanoma, you know that it's arising from a different cell altogether, from the melanocytes. And the melanocytes are the cells that you have that are actually giving you the pigmentation of your skin. So even though these are the most dangerous, luckily it's the ones that are not as common. They're only make up about 5% of the skin cancers, so much less common. And again, they're arising from the melanocytes, a cell that secretes melanin. And there you can really see in the picture how it's darkened, right? And that's secreting too much of this melanin. And they may metastasize quickly, which means some of these cells may end up in circulation, and they can either move around through blood or through lymph and end up in a different part of the body and then start doing this terrible trick, which is to over-reproduce and make too many cells, forming a growth. Okay, so that's the introduction of these cancers, and now we're going to go look at the cells themselves. And I start out with showing you this diagram, which is so dramatic, and it's from Gunther von Hagen's Body Worlds. I don't know if any of you had the chance to go to see the exhibits. And here's an individual who was a German in Germany who got these master dissectors, and they made the most beautiful dissections of the human body, and then they were really good about preserving them, and the way they did that is in a form called plastination, and it's kind of like putting resin on the surfboard, where they put resin on the muscle so it ends up almost like plastic, but in reality the original muscle there was truly the muscle of the individual who donated his body to this team. So if you haven't seen this, then when we're back being able to go to museums, it's really wonderful. At first, they tried to come to the Smithsonian in DC, and it was actually banned because it was just too creepy. And then it was such a success in Europe that the Smithsonian said, well, let's give it a try and see what happens. And it was such a success that it then went to all over. I saw it in San Francisco, I saw it in San Jose, in LA, I went to quite a few of them. So if you get to see it, it's great. So here, they've peeled off the entire skin in one piece, which is alarming. And then they have this human sort of holding his own skin. So if you could advertise skin on TV, this is what it would be like. Would you be enticed by an ad for a Wonder Coat, which is 20 square feet? It is waterproof, it stretches, it washes, it's permanent, it repairs cuts, it repairs burns. It can defend against infection, which is a good thing because it's exposed to the outside, right? It has a lifetime guarantee. It protects from drying out and disease, drying out with a little lotion now and then, and disease, and it insulates, it synthesizes vitamin D, and you can get it all for $29.99. It is a Wonder Coat, right? It is a pretty amazing organ, this skin of yours. So let's go to more about it. So we're going to look and see that it's made of which tissues and made of which cells. So if you look at it first here, right, this is a cross section here of skin. Look at all the tissues that you would see there. So along the top here, you'd see an epithelial tissue. Here I can see muscle. Here I can see fat. These vessels is blood. There's neurons. So an array of tissues that make up skin, right? And what we're going to look at are these layers. So here they're labeled for you. This very tiny little top layer is the epidermis. This is what you saw on slides. You know, the microscope slides, but you saw them as pictures, where you had several layers of flattened cells, right? And then there's the second layer here, which is the dermis. And then you go belong to the hypodermis. So epidermis, dermis, and hypo below dermis. We'll be talking about those. And they look pretty distinct, those layers. So let's look at the cells. The first one we're going to look at, just like we have before, is what are the stem cells of this system. So your skin has a lot of undifferentiated cells. If they're undifferentiated, it means they haven't yet committed to being a skin cell. They're flexible. They're able to be a different type of cell. So they're not yet an adult. They will undergo mitosis. They will change. They will divide and change. And these are found deep in the epidermis. Epidermis, which is that very top layer only. So we're looking at that very top layer only with all these, remember, squamous cells, you were looking at them. So this very top layer here, from here to here, is the epidermis. That's what we're looking at. And let me backtrack one thing. So we have the stem cells that are deep in the epidermis, and I'm going to show those to you. Look here. There is a cell that's undergoing mitosis. So that's a cell that's undergoing division, right? It's going to divide and push up towards the surface. And these are the cells up here that are dying and then just flaking off. So these are those basal cells. So when you talk about the basal cell carcinoma, you know that it's occurring in these cells of the lower layer of the epidermis. Now, keratinocytes. Okay, so keratinocytes are the majority of these cells that you see here. Okay, and they are able to release keratin. And what's keratin? It's waterproofing agent that you have so you don't get soggy when you go out in the rain. Okay, a little more about keratinocytes. They're the most abundant, right? Those are the ones I was showing you. Lots of them. That's what's going to make up the majority of this tissue. They're made from stem cells. So originally they were a stem cell that then divided and became a keratinocyte. They produce keratin. So it's this tough, waterproof protein, and water's going to be able to beat up on your skin and not absorb it all. And these keratinocytes also produce antibiotics, which is really nice to have antibiotics on our skin so that we don't start growing all sorts of moles on the surface. Phone ringing. Just gonna let it ring. They are dead at the surface. So these keratinocytes when they as they rise from the basal layer, they will rise up to the surface. By the time they reach the surface, they're dead and they're going to flake off. So that's kind of the lifespan of a keratinocyte. You know, starts out as a stem cell, becomes the keratinocyte, and then it goes getting flattened and flattened closer to the surface, and then flakes off. They have, what lifespan is that? And this is how long it takes you to lose your tan, right? About a month, anywhere from 35 to 45 days, where they start to flake off and you've lost your tan and you got new cells coming on from below. All right, so we've looked at stem cells, we've looked at keratinocytes, and now we want to look at a melanocyte. And remember, this is one of the bad cancers, a melanoma coming from these melanocytes. So this is a drawing of a melanocyte, but it's very accurate in that it has these extensions. So what a melanocyte will do is it has to produce melanin for your skin, but instead of having them wall-to-wall carpeted, your skin full of the melanocytes, it has fewer but larger of these cells that can manufacture the melanin, look, and come and dump it on this cell. And then this extension's coming and it's dumping it on that cell, and it's actually dumping it on this cell. So it can release it from here, and you notice how then this is like a CAPTCHA. Show all the cells that have melanin. And all these cells here have received melanin from that one melanocyte. Okay, that's how they work. Okay, the next one is a tactile cell. So these we don't have a whole lot, but these are our receptors. So we have a bunch of receptors for touch. You know how both in our fingers and throughout our body we can feel if something came up against us. And they look very different. You know, this is an example of one for touch or pressure. So if you push on the skin here, it's going to distort it. That's how these receptors work. All you need to do is distort it, change its shape, and it fires a message saying, oh, something's touching me. These Merkel discs are higher up here. They too are a neuron, Meissner's corpuscles. So I just want you to know that these, as a group, these are all cells that are tactile cells that are there embedded in the skin so that you can detect your environment, know if something's hot, know if something's cold, know if there's pressure coming in from the outside. Tactile cells. Specifically a Merkel cell. I think I'm going to skip this. I was going to tell you more about it, but I don't really need to. I'm going to skip that there. Show you some of these other ones. A Meissner corpuscle, really, it looks really complicated, but all it is a neuron. It's going to coil like this. And then anytime that you have pressure coming from the outside, from the cells, it's going to at some location distort, right? Cause a distortion on this neuron, and it's going to be able to fire a message to your brain saying, oh look, something's touching me. So these are more sensitive touch, is a Meissner corpuscle, And a Pacinian corpuscle is one for deeper pressure. So in a deep massage or something, you have, again, neurons that are coiled around these collagen fibers. And the distortion of these, the touch of these, the deep pressure is going to fire a message to the brain telling you that something's there, something's touching you. Okay, yet another type of cell, not a sensory cell, but an immune cell. So this big green guy illustrated here is a dendritic cell. And these are going to be originating not in the skin, they're going to be made in the bone marrow, and they're going to migrate towards the skin. And they're going to just police this outer surface of your body. So if there's that little mold or fungus that's coming along, they're going to try and take care of it. And they will travel to lymph nodes and warn, hey, I need backup. I need some white blood cells to come out here and just, destroy some of these invading cells. So those are dendritic cells. In this diagram also you can see the melanocyte down here, see? And then the basal cells and the melanocytes. So that is a list of all the types of cells that you can find in the skin, embedded in this layer here of the skin. Okay, make sure you know those. Make sure you know the names of all those different types of cells. Excuse me. So back to a little square that you cut out of the skin with an epidermis, a dermis, and a hypodermis. I think I'm going to stop it here. I'm going to stop it right here, and we'll continue on in our next mini lecture on these different layers of the skin and what happens in each. Thanks.